more parts of a circle, more vocabulary. First part is a central angle. A central. Now look, guys, this whole unit, 16 days, however how many days it is, I'm going to show you a lot of angles that can be drawn inside and a lot of angles that can be drawn outside the circle. This is your first one that can be drawn inside, which is a central angle. What makes it a central angle? The vertex, where the two rays meet of an angle. The vertex has to be the center of a circle. So my circle O I have up here, I should probably tell you that, huh? Circle O up here, a central angle would be angle AOB. All right, angle AOB would be considered a central angle. Don't do it on your diagram. Let me show you on mine an angle, another angle I could draw inside that's not considered a central. Watch. See this one here I'm drawing in, inside? That's not a central because the vertex is on the circle. It has to be the center. It has to be the center, okay? So that is a central angle in a circle. The vertex is the center. Next up, an arc. I'm sure you've heard of it, but what exactly is it? It's a piece of the outer edge of the circle. All right, so for instance, I'm going to highlight AB right there. That's an arc. Okay, that is an arc. Notation. You guys know how to write line segment AB, right? You know how to write line AB. How do I write arc AB? Here's the symbol for arc. I'm not really too sure how to describe it. Maybe an umbrella or my face when some of you walk in the room every day. Too harsh? Too harsh? Can't take it. Oh, what if he's talking about me? Oh,
Give names. Who are you talking
about? Yeah, I know. Who knows, you know? That stinks, huh? Underneath it are the endpoints of the arc. So the one I just highlighted up here, arc AB. Now I understand some of you, you're in this honors math class, and maybe you're thinking to yourself, wait, whoa. You write arc AB. How do you know you're talking about that one? How do you know you're not talking about that arc AB? Valid question, right? Well, if I wanted that other one here that I just highlighted awfully, I'd name it arc A, and see how I put that point C there? There's a reason, because I want you to go from A to C to B. All right, so that's the difference in the two arcs. If I say arc AB, I want you to go right from A to B, no points in between. ACB, I follow the order. All right, I follow the order now. Questions on how to name an arc. Name an arc using the symbol. All right, let's put the two together. Your first circle fact of the unit right now. First circle theorem, whatever fact, theorem, I use them interchangeably. The measure of a central angle. So how many degrees in a central angle? The measure of a central angle always will be equal to the measure of the connected arc. I'll explain exactly what I mean here in a minute once everyone copies it down. So the measure of every central angle is equal to the measure of the connected arc. Here's what I mean. Go back to my diagram up there. Remember central angle AOB? Let's say I give you the fact that central angle AOB is 72 degrees. Based on this theorem, arc AB is also 72 degrees. Now, what do you mean the arc is 72? Remember yesterday I said, give me some circle facts, and somebody said, how many degrees are in every circle? What'd you say then, Matt, if that was you? 360, right? So what that means is this is 72 degrees out of a total of 360. That's what it means. But, whoa, what just happened there? Whew, all right. Whatever the central angle is equal to, it's equal to its arc measure. Right? They are always equal to each other, those values. Questions, comments? All right, here we go. 3 special arcs I need you to be aware of. 3 special types of arcs. A semicircle, I think we've heard of that term before. Half a circle. So how many degrees would be in a semicircle then? There'd be how many degrees? That's what I thought too. How many degrees in a semicircle? You guys kill me sometimes. 100. You want to know all about my life, but then I ask a question and nothing, right? 180 degrees. Yep. Well, what if an arc is bigger than 180? We call it a major arc. Major sounds important, huh? Major arc. And if it's smaller than 180, a minor arc. So I have 3 diagrams down here, and I need you and your group to complete a task for me. In diagram number 1, I'd like you to identify a semicircle in number 1 using our new arc notation, please. So identify a semicircle using the new arc notation. Diagram 2, I would like you to do a major arc for me. Identify a major arc using our new notation. And I think you know what's going to come last here. Give me a minor arc in diagram 3 using our notation. Go ahead. Semi, a major, a minor. All right, here we go. Semicircle for me. Give me a semicircle. Ho, Gianna, semicircle. TRS, I like it. If anybody had TS going this way or ST, that's fine too. All right, perfect. Major arc, second diagram. Major arc. All right, who are we getting on here? John, I already heard from you. We'll hear from you in a second again, I bet. Zoe? RTS, good. If anybody had STR, just put it in a different order. You're good. And then how about my minor arc here? Minor arc. Oh, Ian, good job. Good talk. Good talk. Hey, how about ones? Will? RS, thank you. If anybody had RT, TR, SR, all acceptable. All right, all acceptable. No other questions there on the types of arcs. All right, now I want to use our fact now in algebra questions. All right, that the central angle is equal to its arc measure. Let's use that in a couple algebra questions here. All right, we got circle C, so we identify C as the center. Find the measure of arc AE. So how many degrees are in arc AE? And remember, an arc is always equal to its central angle. Here we go, 1-6. Zeev, I don't want the answer. I just need you to a couple lead-up questions here. Arc AE belongs to what central angle? Name the central angle that belongs to ECE. Do you know how many degrees are in ECE? Angle ECE. You are correct. How many degrees are in ECE?
90.
Yeah, don't overthink it, right? It's right next to a right angle. 90, so that means its arc also has to be 90. That's the fact we just wrote down. Any central angle is equal to its arc measure. All right, let's do this one more time before I let you do 3 through 6 on your own. Arc ED, here we go. Gabby, before you tell me what it is, arc ED belongs to what central angle?
ECD.
Yep, ECD. Do you know the degree measure for ECD?
Yeah,
50, because it's supplementary to the 130. So arc ED will also be 50. All right, everyone starting to see this theorem be put in use? 3 through 6. Go ahead, 3 through 6. Follow the order of the letters. Let's start with number 3, arc DBA. Arc DBA, what are we looking at here? All right, start us off right, Haley. DBA.
220.
220, good work. 220 degrees. How about arc AED now? Arc A to E to D. Looks like you had to add a couple arcs up there, huh? AED. Going back, Gabby.
140.
Buck 40, good work. How about ABD? I don't know if anybody saw the relationship between another problem and this one, but not until you finished it, probably. 2, Zoe. 220. It's the same arc as DBA was in number 3. And then finally, arc BD. Let's roll. Finish this in style. Aiden.
130.
Buck 30. Great work. We all good? All right, we're good here. Now let's go down to circle S. Ooh. Find the measure. How many degrees are in arc AB? But I got a problem. I don't know the central angle. All I know is it takes up 20% of the circle. Ooh, no central angle to look at here. Can you find the central angle though? If you know it's 20% of the circle? All right, talk to me. How can I locate what the central angle is going to be? Zeev?
Take 20% of 360.
There you go. All right, let me just write that. We're going to take 20% of 360. Why 360, Zeev? How many degrees in the whole circle? How do you do that, by the way? There's a couple different ways I could take 20% of 360. Anybody have a go-to method here? Zeev, go ahead. Keep going. Your problem.
Multiply it by 0.2.
0.2, yep. Anybody doing the proportion? I think it's 20 over 100 equals x over 360. I guess that was something that came up in my previous class that you could do. And Z, finish it. How many degrees am I looking at then?
72.
72. Yep. All right, let's just do it one more time, but now for arc CD. Arc CD, 18%. So it looks like 18% of 360 degrees. And what are we looking for there? How many degrees? Josh?
64.8.
Oh, thank you. All right, any questions? I'm going to do a little intermission here. Any questions there? Because what we're doing the finish class off here is a little bit different than what we've done the first half. Any questions? Labeling an arc, finding the arc measure, it's equal to its central angle. A lot of vocab I threw at you here already. All right, here's where we're going now. And I want to make sure you guys, before I show you how to do it, I want to make sure you know the difference between what we've done already and what I'm about to show you. What we've done is how to find an arc measure, which is in degrees, right? How many degrees out of 360 is. Now what I'm about to show you is how long an arc is. All right? Measure of an arc is in degrees. Length of an arc is basically if I took AB, cut it out, stretched it out, and put it in front of a ruler, how long is it? 2 inches, 3 centimeters, etc. So that is what I'm about to show you right now, is how long an arc is. Measures in degrees. How long it is your second formula of the unit. All right, so this is what we're finding, the arc length, not the arc measure. Make sure those two are clearly separated. Arc length, how long AB is. And here's the formula. Not on your formula sheet, by the way, so your responsibility. It is the measure of the arc. So we're going back to the degree measure again. You take the measure of the arc over 360. So we make what fraction of the circle is it? That's what we're talking about. Degree measure over 360. And then we're going to multiply that by a formula we're pretty familiar with. And that distance. Pi d. What's that formula for again? That's the center of the center. That's the circumference of the circle, right? So I don't know if it's kind of clicking a little bit where this formula comes from. So what part of the circle for its circumference? We're looking for what part of the circumference is the length. Okay, so that's where this comes from. A fraction of the circumference. All right, let's use it. I'll have to add this into the notes next year, but number one is minor arc AB, okay? We're looking for the length of minor arc AB here. Again, don't tell me it's 90. That's the measure. All right, that's the measure. I'm looking for the length now using this formula, and I kind of already gave this away, but here we go. What are we going to put over 360? What is the measure in degrees of arc AB? Measure in degrees of arc AB, Doyle? 90, yep. So I put 90 over 360 times pi d, and 24 looks like it's the diameter. So pi times 24. Anybody sniff out those directions yet? Ho! Same thing in terms of pi, like we had yesterday, which means leave the pi in your answer. Don't press it on the calculator. And I know some of you are getting a little confused. Let me help you out. All right, so what do I type in the calculator then? Everything else. You put your pi in your answer to leave it in terms of pi. Now I do 90 over 360 times 24 in my calculator. I type in everything else that's left. And then that answer will be in terms of pi. And what do we get there when we multiply everything else? Hey, Haley!
6 pi.
6 pi, yep. Now, I always think, like, it doesn't mean much to you. Like, 6 pi, that's how long the arc is. Everyone do 6 times pi in your calculator right now. That's how long the arc is in inches. Okay, so if you wanted something to look at, all right, I just like it in terms of pi. It's clean. All right, I don't have to write to the nearest hundredth, tenth, or all the decimals written all out. This is nice and clean. But if you want to know actually how long it is, do 6 times pi. All right, one doesn't make you great. Let's keep going. CDE. CDE. CDE, the arc length. I keep exaggerating that because what is the arc measure of CDE? Arc measure of CDE, 1 zip. Matt, what do you got back there, stud?
320.
320, good. We're not using 40 here. We use the other part of it, 320. Over 360. Check your work too if anybody's getting ahead of me. If you're doing 9 pi, you're doing radius. Pi radius. It's pi d. Pi d. So make sure there's an 18 in there. Please make sure there's an 18. And in terms of pi, Olivia, hello.
16.
What do you have?
16.
16 pi? 16 pi? I just had to confirm. I don't have it in front of me. Not like I believe any of these people up here, but. One more. F, G, H. Please follow the letters. F to G to H. What is the length? The length of the arc. All right, what's the measure first? Let's start off. What's the measure of FGH? Will, hello? Good, 135 degrees. Add in that 90 and 40. Put it over 360. Again, be careful. Don't use the radius. Double that sucker before you plug it in. 6. Bless you. I'll accept the fraction or decimal. It doesn't matter in terms of pi. Gianna, what do you got back there? Told you you were getting called on again.
9 pi divided by 4.
Good. 9 pi over 4. I would also accept 2.25 pi. That's fine too. Measure of an arc in degrees, length of an arc is your formula. Questions before we get to the honors level question to finish it off going into the weekend? Let's do it. Oh, I love this one. It combines day 1 and day 2. I love it. All right. Find the circumference of circle D. Before I read on, what formula am I going to need then? I'm finding the circumference of this circle. What formula? Pi d, right? Pi d. This doesn't seem too bad. And we talked yesterday, what's the only value I need then? If you're going to have me find the circumference, all I need to find is the what length? Diameter length, right? So, all right, that's all I need to find here. What the heck is the diameter length? Easier said than done, though, kiddos. Easier said than done. All right, let's keep reading then. I give you this 6.09 inches. That's what? 6.09. That's the length of arc JK. Seriously, it is. Seriously, it's 6.09. You like that, Gabby. I could tell. Right? Never mind. Some of you still, it's all right. We'll fill you in later. All right. Anyway, it was good. It was good. The cornier, the better. Yep. Guys talking about street lingo here, huh? Got me, Josh? JK? Seriously.
What?
Come on. You don't. Come on.
I wasn't listening.
You're killing me here. Never mind. The arc was JK. Just joking, and I kept saying, seriously, it's 6.09. Seriously, it is. Yeah, it's pretty good. I know. Yep. All right, anyway, we still have to find this diameter. All joking aside, we got to find this diameter. 6.09 is the length of that arc. Don't you have a formula for length of an arc where that 6.09 came from? And what's included in that formula? Diameter, isn't it? All right, look, here's what I'm talking. You don't have to write I'll rewrite the formula now. You don't have to write it down. Here, length of an arc. We said today was what? Measure over 360 times pi times D. So if I could take my 6, where should the 6.09 go in then? Length of an arc. And now take this formula and solve it for D. Before I do that, what is the measure of the arc? 50. So does everyone see where we're going now? I'm going to solve for D using your algebra skills. Solve for D, substitute it in. That's my goal. All right, algebra studs. I think there's a few in the house. How do I get D by itself? What do you want to move over first? Nothing? Me neither. What would you like to move over first?
50 divided by 360.
Okay. How do you want to move 50 over 360 over? Because there's 2 different methods I could move it over.
Subtract it.
That is not one of the 2.
Like, can you just
subtract it?
Can you subtract?
It's all being multiplied though.
By what? Oh, okay.
All right.
All right.
There's no, yeah. Hey Josh, if I put a plus in between here instead of a, yeah, okay, you got me there. But no, it's all being multiplied. So you want to revise your answer on how to get 50 over 360 over?
Divided by.
I could divide it over, or I could also multiply both sides by reciprocal, 360 over 50. Your call. All right, move it over. Go. Move it over. Either divide both sides by 50 over 360 or multiply both sides by the reciprocal. $43.848. Yeah, everyone's good? All right, now, how do I, D still not by itself? How do I get D by itself? One last step. One last step. Divide both sides by pi. Amy, don't say a word and steal my fire. Got it? Don't say a word. Don't say a word. Just keep dividing by pi. Let's go. Don't say a word. You're correct, Haley, too. I have no problem with that. And everyone's going to get a long decimal, right? Yes, everyone's going to get a long decimal. Okay. Take that long decimal, substitute it in, and finish the problem. Okay, go ahead. Let's go. Okay, I'm not putting up an act here. We're solving for the circumference here. So you take that long decimal, substitute it in, multiply it by pi, and what do you end up getting? What, 40, what's this one? 40 nearest 10th, 43.8? Yeah, 43.8 inches. Got a little awkward here a couple minutes ago, right? Right at this step right here, when Haley told me to divide both sides by pi. All right, there was some awkward silence, looking around, facial expressions when we were here. Here's why. Pi d, what's that another name for? So there was my answer right there. Okay, if you saw that. If not, hey, if you didn't see it, who cares, right? Did we get 43.8 at the end? Yeah, we did. Okay, so again, this was just another name for the circumference if we saw it or not. So we didn't have to divide by pi, but it would still get us to the answer.